to eat. All right, pause your order. That means I have my physical need met, I have where to stay, what to eat, and all the necessary stuff. I have my psychological and emotional need met, and all of those things. And most importantly, I have all the necessary need I have before I can say I'm self-fulfilled. I can't say I'm self-fulfilled if I probably I don't have where I'm staying, I don't have a house, and all of those things. So Monica relates that to the hierarchy of needs, that an organization cannot claim to be data mature, or an organization cannot claim to say they want to do some advanced analytics like AI, machine learning, without having all the necessary needs in the pyramid myth. And this came into light as a result of the explosion in data science, AI, way back in the 2010, 2012, 2014, where after the Harvard article got released that said data science is the sexiest job in the 21st century, many organizations jumped on that article and felt like data scientists were going to be the savior of the organization to help them to churn out amazing insight that is going to help them triple their revenue and all of those things. Even though, yes, data science is going to do those things, but they fail to realize that before they can do all of those things, all of those advanced analytics, all of those predictive modeling, and those things they really, really want to do, leveraging that data, they have to have the right need met, which is they need to have some of these base need in the pyramid met. They need to have the right infrastructure in place that will support collecting the right kind of data, because garbage in, garbage out. If you're not collecting the right kind of data, if your data is not being properly stored, that means you have bad quality, bad kind of data, which you produce bad quality of data. And that means when you're modeling your data in terms of predictive and machine learning algorithm, you definitely will have bad insight, which would affect whatever decision you want to make. So that means garbage in, garbage out. You want to ensure that before you even start out anything called advanced analytics, anything called reporting, you want to ensure that the pyramid is sorted. You have a place where you are collecting data, seamless flow of data from one point to another. You have a place where you know that your data is properly stored and archived. And most importantly, you already have a transformed data ready for use to make that process of doing whatever reporting and whatever advanced stuff you want to do. And that's basically what Monica is trying to explain, that before any organization can do this stop in the pyramid, which is doing those AI, those deep learning stuff, and even some of those analytics stuff they want to do, they need to ensure that they have all the necessary things, from collecting data, from moving data from one source to another, and ensuring that the data is clean, which is exploration and all of those things. And that's why it seems as though there's not like a bit of orientation after organization has really dived into that explosion, trying to say, oh, here, let's say a data scientist is going to get stuff done for us. And they now failed. And that's why many data scientists were actually set up for failure, because most of them end up joining organization. And is either data is not available, or data that is available is not yet ready. And that means most data scientists end up doing the work of a data engineer, because before you can do any modeling, you have to make data available for yourself. And that's why I say a lot of data scientists now start wearing multiple caps. But all thanks to the role awareness that is now going, our organization is getting to see the need for data engineers at the web. And that being said, now, after organization realized that yes, the need for infrastructure, right? Now, what we've seen is that before organization can set up a data infrastructure, there's a lot of capital requirement. It's really, really capital intensive prior to the cloud data cloud era, which is prior to the 2010. So before, when you start having likes of Redshift, likes of Snowflake and BigQuery and all of those things. So prior to then, most of what organization basically used to do is basically leveraging all distributed systems, the likes of their Hadoop, the like of all those on-prem infrastructure, which require a lot of technical resource, a lot of folks that are really skilled in this stuff. And that means organization cannot just wake up and say, oh, we want to become data-driven. And for us to become data-driven, we want to set up a data infrastructure. They can't just wake up and say they want to do that. That means they have to plan upfront how much it's going to take, cost them. They have to plan upfront who are the technical resources they will require to do those jobs, which is often very tedious. And that's now why, because now we didn't have what we have now, which in terms of processing power, computing resource, and all of those things were not available. And that's why there's not like a paradigm shift many organization leverage at that point in time. Now, the paradigm shift is what we call the ETL, the paradigm shift, which is what saying that now we know that we are constrained in terms of data that we can process. We don't have all the available resource, right? So that means we need to ensure that whatever data that will be loading into whatever platform that I want to use, which is our data warehouse, we want to be sure that that data is exactly what we need, because we know that Processing power is very expensive. Storage is also very expensive, right? And that's why they have to ensure that whatever gets loaded into their warehouse is ready for use, cleaned. So you talk about the extract all data from all the different data sources, do what is called the staging layer is available, another staging server where they will store or do all necessary transformation, and they finally now load the data that they need for transformation. Now, this paradigm shift actually help them at that point in time. But like I said, this paradigm shift basically require a lot of technical resource, require a lot of capital requirement. That means you have to factor in buying server where you are going to store your staging layer for you to move all your data. And before you now start saying you want to move into the data warehouse, you don't necessarily thing you want to do. So like I said, this is basically what it looks like. Now, there are a lot of challenges that exists with that. So what happened when you want to change anything in your final layer? Let's assume you are downloading data into your data warehouse. And a stakeholder now said that, oh, I have a particular metric or a particular report I want to build. That was not necessarily factored in when that data pipeline was built. Now that means they have to go back again, do the ETL again, do the staging layer transformation again before loading it. So it can take a lot of bottleneck, because that means they have to wait for the engineer to do that again, because it's not something anybody can do. You require technically sound folks that can do that. So it was basically difficult for it to scale, and maintaining it also was very, very difficult. And that's what that paradigm shift existed. But now, all thanks to the cloud infrastructure, the rise of Redshift in 2012, that brought about accessibility to high computing resource, high storage that are relatively very, very cheap. As an example, BigQuery, you can store about 1 terabyte of BigQuery for about $0.2, which is relatively very cheap. So you don't necessarily have to bother about storage. You don't have to bother about computing resource, because these things are readily available. And now, what then that means is that organization can now set up their data infrastructure without necessarily thinking upfront like, oh, cost is going to be expensive and all of those things. And now that's why I talk about the rise of all of this cloud data infrastructure, the Snowflake, the BigQuery, the Redshift, the Azure Synapse, and Azure Data Factory. So all of those cloud infrastructure basically now give rise to a new paradigm shift. Now, what's the paradigm shift that we now have? Now, I'll explain how that connects to analytics engineering. Now, the new paradigm shift we now have is now the ELT paradigm shift. And now says that now that we know that storage is not the issue, we don't have issue with storage, and we don't have issue with computing resource, why not let us just load all the data that we have from all the different data sources and just load them into data warehouse once and for all. And at every point in time, we can always refer them to do whatever thing we want to do. So that means even if we are done transforming our data and we now discover that, oh, we need to do, we missed out a particular metrics, or a stakeholder reach out and say, I need a particular feature, a particular column in my report, we don't need to bother ourselves to want to load the data again from all the different data sources. All we just need to do is make reference to the data sources, the data that we've already loaded in data warehouse, and we don't have to bother ourselves again. And that basically make it seamless. So all the bottleneck that existed in the previous paradigm shift, which was as a result of some of the constraints they had prior to the cloud infrastructure, were now eliminated and mitigated. And that's now what we now have. So now this now become very much easy, and everybody now have access to all the data that they need at every point in time. So now, how then does the analytics engineering space now erupt? Now, like I explained, before the cloud data infrastructure, after organization came to realize that, yes, for data scientists to be able to do a lot of all of their stuff, they need data infrastructure to be in place. And for data infrastructure to be in place, they need technical sound folks that can set up that data infrastructure. And those folks are very, very scarce. And that's why, if you've been seeing a lot of data engineering recruitment, and you would confirm that these roles are very, very difficult to hire, because it's basically, a data engineer is basically a software engineer who is dedicated to data work. They basically are software engineers because they do a lot of technical stuff. So the skill set is very, 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 very niche and very, very difficult to find. And that basically means that many organizations, because they find it difficult to hire these guys, they find it difficult to set up the data infrastructure, to start enjoying some of the data initiative they want to do, right? The whole idea now came relating to how can we empower. Now we know that data engineers are scarce, but now in the data ecosystem itself, we know there are some set of people that all over the place. We have a lot of them who are the data analysts, right? These guys, before you see one data engineer, you probably would have seen like 10, 20 data analysts, right? It doesn't mean their work is very easy. It basically means that, yes, those guys are just downstream the ecosystem. They interface more with the business, and I guess that's why you need more of them. Now, we have a lot of all these guys. Is there a way we can empower these guys such that they'll be able to do, as it were, some of the jobs, some of the role of a data engineer, in quotes, some of the things a data engineer would do for any company at their early stage in the data maturity of that organization? So how can we empower these folks such that even if, yes, they may not necessarily be a data engineer, but they can do, as it were, what the data engineer would do, which is make data available, consolidate data from all the different data sources, ingest data to whatever destination data will be, and also do some form of data transformation such that whoever will get the data has a well-prepared, well-formatted data ready for use. And that's when you now have the rise of what is called the modern data stack. So the modern data stack is now saying are basically some set of tools that are empowering data professionals who are not so technical as they were to be able to do a lot of what data engineer would do. So instead of having to write a lot of custom code to ingest data from, say, MySQL to a data warehouse like Snowflake, you can easily use some of these tools as an example, say Fivetran. So you can easily use some of these tools, say as an example, Fivetran, to ingest the data from one source or the other. And if you want to do your data transformation, now that you've just ingested your data from whatever sources it is to destination, you want to make it ready for use. And we know that, yes, researchers say 60 to 70% of the work of a data professional, whether a data scientist or a data analyst, is in data preparation. So how do you now eliminate that work such that each of all those downstream data professionals don't have to spend a lot of time doing all of those things? How can you make that work a bit, that workload reduce? So you want to do a data transformation to remove all the necessary data that you don't need. And that's where a tool like DBT is coming in to do their data transformation for you. And you talk about visualization itself. So that's just the whole thing modern data stack is trying to achieve. Basically saying empowering data professionals who are the data analysts to be able to do, as it were, what data engineers would do. And that's now why we now have the rise of what is called the analytics engineer or analytics engineering as a space. So analytics engineers are basically the middleman between the data engineers and the data analysts. So see them as folks that would do what a data engineer would do, and they will also do what a data analyst would do. So that's why it's just more or less like 2-in-1 role. Because so that means if an organization does not have a data engineer, an organization does not have a data analyst, if you have an analytics engineer, at least in the first few years of the organization can easily set up a data infrastructure, can easily power the reporting, make data available for you, such that at the time the organization is ready to hire a data scientist, whoever will be data scientist that will be coming on board already have a good data ready for use, and he or she would not have to start doing a lot of data preparation, data munging, and all of those things again, because all the data scientists will just need to do is connect to the data warehouse, to the right schema where the right data is, and he or she can start building up their machine learning algorithm, their EDAs, and those interesting stuff they need to do. And that basically means that all the downstream professional will spend more time in what they ought to do initially. Now, because prior to the role of analytics engineer, like I said, a data scientist would have to wear the cap of a data engineer. So that means if you are a data scientist and you're unlucky, you join an organization that does not have a data engineer, you join an organization that does not have a data infrastructure, that means you have to be the one to do those things yourself according to the hierarchy of needs. You can't do any machine learning algorithm if you don't have a data available. And that means you have to set up a data infrastructure, find a way to ingest your data from whatever it is to where you want to use it. And you want to start now do your data cleaning before you start building all your machine learning algorithm. But now think about a world where you don't have to do all those things again. And the data you are getting is fit for use. You don't have to start doing check whether there's null. You don't have to start checking whether they are duplicates. You don't have to bother about all those things again. But in a world where the data you're connecting to is already clean, the data you're connecting, there's no duplicate, all you're just doing is you are diving right into your EDA, finding all the insight and building your machine learning algorithm and deploying. That's just it. So you have all the time to concentrate on what really matters. And it's for a data analyst. You don't have to start bothering whether there are issues in the data. You just dive into exploring the data and finding all the insights. And that's what we have now in what is called the modern data organization. So the modern data organization is basically empowering all the different data professionals in the whole ecosystem, whereby now the data engineer itself, now doesn't that mean we'll not have data engineers? No. So what we then have will be the data engineers would then focus on what they love to do more. Now, I've worked with a data engineer in multiple clients, and most of those data engineers don't, as it were, like to interface with a lot of all the stakeholders or have to do a lot of all this transformation and a lot of those things. You probably bore them. Most data engineers, like I said, data engineers are software engineers, but dedicated to data products. So they are more interested in doing a lot of infrastructure work, platform work, optimization, scaling infrastructure, and all of those things. Those are things that interest them more, right? They don't necessarily have to start asking stakeholders, oh, what data do you need? What formats do you need the data? And all of those things, right? So the analytics engineers will be the ones to do those things, right? And the data engineers can focus more on the infrastructure side of things, scaling those infrastructure. So the data engineer will be more horizontal, make data available for everybody, while the analytics engineer would be more vertical in the sense that you work interface more with the stakeholders, interface more with different niche area of the business to understand what are their needs, what are the things they want to do, what are the kind of data they need, what are the metrics they want to build. And based on the data that is already available, either provided by a data engineer, if your organization is a big one, is a large one, but if it's a small organization, that means you can easily set up a data infrastructure yourself to make the data available, and then you can design and transform the data in a way that is fit for purpose for all the different stakeholders, who in this instance can be a data scientist, or can be a data analyst, or can even be a stakeholder that just needs some Excel report to do whatever decision they need to make. And that's just basically what the whole analytics engineering is. It's currently one of the hottest data role at the moment, which is really, really getting a lot of ground in the global space because organizations know that they are finding it difficult to hire a data engineer, like I explained. So they are seeing these folks as folks they can hire in the interim, at least for the initial stage of the company. And as they scale, they can now see need to hire more data engineers and other, say, data analysts and the likes, right? And that's just what we are saying. So, and then now the question now is, what's now the role for me as a data scientist? Does it not mean I need to learn this tool? Basically, well, it's probably will be a yes or a no. So it's all depend. Now, if you are in an organization that probably already have a full-fledged data team, I think there probably would not be any need, but maybe just having an idea of what the tool can do can just be good, right? Because you're a data scientist, not a data engineer, aware, but probably just having an idea of how the tool operates and all of those things might be good. Probably should, in case you end up getting into an organization that use this tool, so you are not entirely just lost in what the tool can do. So you don't necessarily have to go deep dive into learning all the nuances of how DBT and all of those things work, but just having like a mental knowledge of how this whole thing basically works if you're a data scientist. But if you're a data engineer in the interim, I think it's probably a tool you need to add into your stack, because it basically just give you a leverage as it were, knowing that, oh, you know when to probably switch to a tool like DBT to do your transformation, or when to do your necessary transformation in another tool. So it basically just give you that ability to have options to do a lot of things. And if you're a data analyst, I think definitely adding DBT to your stack definitely give you a hedge over a lot of people, because not many people in the moment actually have competence in DBT as a tool, because it's still in the nascent state, it's still very young, it's still very, very new. So there's still a lot of learning to be done. So adding DBT as a stack, as a tool to your stack, definitely puts you in the hedge. So that's pretty much it. Relating to the value, I'm sure you can have an idea of what value the modern stack can give in terms of it's easy to set up, unlike the previous paradigm where you need a lot of costing and you need a lot of technical competence as it were. But what modern stack has achieved, which has brought about the rise of analytics engineer, is the fact that these things are readily easy to set up. You can easily spun up a data infrastructure in less than 2 weeks, and you can set up everything you need to do with all the necessary stakeholders, have a data warehouse and everything running, let's say 2 to 3 months, depending on how skilled you are and all of those things. And most importantly, now reduce a lot of engineering overload, like I explained. Data engineers or software engineers as they were don't get overwhelmed with a lot of things, because now you have a tool that is making all of these things readily available for them to use. So before I proceed, I don't know if anyone have any question before I now go to the main tool which sits at the central of the whole analytics engineering ecosystem itself, which is DBT, that basically help in a lot of data transformation, and how DBT has basically helped data analysts now think and do stuff like software engineers or like data engineers. I don't know if anyone have any question before I proceed. Question from anyone?
Hi.
Hi.
Well, I think I already dropped my question on slide 2.
Sorry, I didn't get that.
I think I already dropped my question on slide 2 with
Oh, okay, let me check that.
blessing. Well, in the interim, let me just ask this: how, because I've been hearing you spaces like Twitter spaces like.
I don't know if I'm the only one. You're breaking. You're breaking. I don't know if it's just from my hand.
Is it better now?
Yes, yes.
Oh, okay. All right. So I've listened to like 2 of your spaces on Twitter spaces, right?
Yeah.
Yeah, you're all over the DBT things, but I didn't understand. I was just following you. It's nice to see your face. Like I didn't understand, honestly. So, my question now, I dropped one on slide 2. The follow-up question is, how do I get to this level that you are? Yeah.
Okay. Is that all?
Yeah, for now. I might still have more before the end of the presentation.
Oh, okay. Because I just want to go to the demo aspect of things. Okay, so I'll just answer the questions here and your current questions. How important is the knowledge of software engineering and engineering? Okay, so interestingly, and that's what DBT is doing. DBT basically, as a tool, which is the demo I want to go into now, is a tool that basically help you treat data as a code. So you basically treat all your data assets, your queries, as though you are a software engineer. So think about all the concepts that software engineers use for building applications: version control, testing, documentation, and all of those things. You literally can do all of those things leveraging DBT without learning any other tool, but just leveraging on the skill set that you already have available, which is SQL. Remember I said the whole idea of analytics engineering and modern stack was basically saying, how do we empower the data professional we already have available to do what data engineers as well would do and share this knowledge? And that's what DBT is doing. So now, what knowledge of software engineering do you need? Now, you basically just need maybe less than 1% knowledge of software engineering, which is learn version control, which is something you can learn in less than 1 hour. You can, the basics of version control that you need for DBT. You can check less than for a 30-minute video on YouTube, be able to come up to speed on how to use Git, version control, the basics. And you can also learn basics of command prompt, which is some of the things I will show during the demo. So if you're able to learn those 2 things, which you can easily pick up, version control and basic of command line, every other thing that you would do as it relates to testing, documentation, or SQL. So that means your ability to use DBT well is a function of using SQL well. So if you're already good with SQL, I can tell you, you would definitely find it easy to use DBT. The only thing you just need to learn is some of the syntax that is specific to DBT, right? So that's just it. So you're not learning, but as simple as it is, you can do a lot of complex stuff. So that means you can write a test to check if your model, in this instance, model is not a machine learning model. Model in this instance, which I'll talk about later, you basically say your SQL query that will return a particular table. You want to test it because one of the principles of software engineers is that you want to write tests for whatever application, whatever stuff you are building. you want to ensure that these things are well tested so that it doesn't break in production. So DBT also enforce that too, that you write tests. Whoever test you are writing to is basically you writing SQL query to basically check instances where that table that you've created, when it will fail. So they're basically all SQL, but embedded in DBT, and that's what DBT is doing, empowering data analysts, data scientists to work like a software engineers, adopt software engineering principles without necessarily having to learn a completely new, different language. And that's basically what. So you don't necessarily have to learn a lot of software engineering, just command prompts, basic of command prompts, how to CD, how to list, just on basics, which you can easily pick up from any of the crash course on YouTube, or version control, GitHub, which you can also easily pick up in any of the crash course on YouTube. So the next one is the chances of analytics engineer in a firm that is DS sent and data engineer. I don't know if whoever asked, I'm not sure I get this part. Is the person on the call? Adiza.
Okay. Thank you, Opeyemi.
Yes,
I have to shorten it because the characters there has a limit. That's data scientist and a data engineer. And my question is, from the minute I joined the call, I think you analytical engineer to me is sounding more like an alternative to when there is no data scientist and data engineer. So I'm thinking of the future that, okay, a firm that has been making use of an analytical engineer. What if eventually they get to employ a data scientist and a data engineer as time goes? Does that make an analytical engineer irrelevant?
Awesome. I like that question. And I think at some point in my presentation, I explained that there's now what is going to be called the modern data organization. And that's what we are seeing in the companies like Spotify. Even, Facebook also have analytics engineers. All right. You can also check Uber. Uber also have analytics engineers. So actually, you know, if this big fan definitely have all of this, they're eyeing for all of this role. That means it doesn't mean to be redundant. Now, explain how will this role now fit into the ecosystem itself. So in a modern data organization, which is what we are having, you will have data engineers, you have data engineers, you have data scientists and data analysts. Now, how do they play their roles? Now, remember I mentioned how that the data scientists now don't need to bother about doing all those initial preliminary data cleaning and all of those things. What they now need to do is they have the right data they need for their work, and they don't do those laborious, those things that cover, as a way that researchers say 60% or 70%, whatever the research, whoever turned out that research, I don't know, but that's what we've seen all over the place. And I think from experience too, a lot of them, you do a lot of data preparation just to ensure your data is ready for use, right? So even if organization hire, it doesn't mean when organization hire a data engineer or a data scientist, the analytics engineer become redundant. Yes, you are correct relating to at the early stage of, say, startup, the analytics engineer is someone they can hire to get things up and running, right? Without spending so much, because you can easily get this person, spawn up a data infrastructure, make dashboards available, and to get all necessary insight any organization can have, right? But now, as the organization now scale, right, they would need more folks in data fold. Analytics engineer won't do the work of a data scientist, so they will definitely still need the data scientist. Only that now, the analytics engineer will now strengthen the data scientist more. To give you a perspective, Carrywise, where I worked previously, have a data engineer, have a data scientist, also have analytics engineers, and all of them are working together. So what then happened is the data scientists know which of the schema in this instance, which particular table they need to reference to build whatever model they want to build. So let's assume a data scientist say, oh, I want to build, say, a churn prediction model. So you're able to know that, oh, I need X, Y, Z data sets. And the analytics engineers can do all necessary, get all the data set, do all the transformation, make data available so that the data scientists know that when I'm getting this data set, I'm 100% sure there will not be duplicates. I'm 100% sure there will not be any null. And I'm 100% sure this data is ready to go. And all I can do is I start doing my exploration and start building my machine learning model. The data engineer, on the other hand, and don't forget, this is the data analysis engineer that will model that data and make that data available. Now, the data engineer, on the other hand, will be focused in doing all the scalability optimization. Now, let's assume they are using cloud infrastructure, so which means these things cost money. So it will be the headache of data infrastructure to see how to scale this thing, to see how to optimize, to reduce costs, to see how they can probably integrate some of new things to make this thing scale much better, and all of those things. So every one of them will be working hand in hand together. So it's not a matter of, oh, one person eliminates the other. It's a matter of everybody are working hand in hand toward making each other's work much easier. And that's what we are going to have in a modern data organization. So you could, probably after this session, I will just check up an article how Monzo is one of the leading fintech in UK, which I really respect so much, how they segment, even Spotify, how they segment all their data team. They have data engineers, they have data scientists, and they have analytics engineers. And the analytics engineers are core to how the right data get accessible to everybody. So I don't know if that answers your question.
Yeah, very well, very well. Thank you very much.
Okay, so so this is very, very, very true, and I think it cuts across all career, not necessarily data. When starting out, you have there are periods you probably don't want to stop learning. And interestingly, the community that I lead, someone asked this similar question. I think she posted that is it normal for you to be tired of learning, right? And it's very, very normal. At some point, lethargy will set in. You won't have any motivation, any drive to probably want to learn. So even make matter worse, if you are probably learning to probably get your first job, it's even much terrible because you're just learning this thing. Opportunities are incoming, rejections are all over the place. And yes, it can get daunting, it can get overwhelming, it can get discouraging, it can get frustrating, right? But I think for me, what kept me going was, yes, I had community, I had people who started out together. So each time I know that, yes, I'm getting a lot of rejection, blah, 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 we just chat about it and get to know that I'm not the only one feeling that way. So there's a way it just kind of rub off. And the interesting thing also is we all can't feel discouraged at the same time. So it's either, oh, I'm probably discouraged at some point in time, but I'm seeing some of the folks who started together, folks within the community, doing some amazing stuff. Probably somebody built a particular solution or a particular project they are working on. Somehow it just motivates me, get me inspired. These people started out together, they're doing some stuff. I can't afford to give up and all of those things. So it just helped me to stay motivated and not tire out. So it's totally normal to get tired. It's totally normal not to feel like learning again. Like it's totally normal. And the response I give to the person that asked that question is it's okay to just take a break. So you could just take a few days or even a week or two to take a break, just to refresh, get that energy back, and then you are back again. And that's what community do for you. So you have community, share your thoughts with the community, how you're feeling, and people will let you know that you're not feeling alone. So community basically was like the major strength for me, because I had people all over the places, different communities that I was able to lean on their energy just to continue, even when I didn't have that energy. I can imagine if I was learning in isolation, I probably would have dropped it and just free it. But because I wasn't learning in isolation, I had a lot of people that we started out together that were in a couple of groups and we're exchanging, just chatting randomly and all of those. So it kind of make it easy for me to just persist. And another thing that also kept me going was knowing that what I'm learning is something that is of high value. So I knew I was learning something that definitely the opportunity may not be there at that point in time, but I know it's something I know that when the right opportunity comes, it's not a skill that would go obsolete. I know it's something I'm learning that I know that 3 years down the line, that was when I started that, 2 to 3 years down the line, I know this is something that will be in high demand. It wasn't the way it is now. I started late 2017, late 2017. So you can imagine we didn't really have a lot of buzz as we have now, where you can get a lot of motivation, see a lot of people already doing well in the space, knowing that, okay, yeah, I think this space is booming. When we started, we didn't really have that buzz. When I started, we didn't have that buzz like that. I just basically lean on the research I made when I started out that, okay, fine, this is a field that has tendency of growing big. So that knowledge of, okay, fine, I think I'm learning something that is of value. So let me just keep at it. Let me not give up. And that basically just helped me. So those two things basically just keep me going. Community available. And that why, knowing that I'm learning a skill that is of high value, that will definitely be in high demand in a few months or in a few years. I just probably just need the right opportunity to set things in motion for me. Just kept me going. someone wants to dive into football analysis, which aspect does he need to? Now, in all honesty, if I'm being honest with this, now when starting out in data, I think you should avoid trying to want to carve a niche immediately, because you box yourself kind of. So I would rather say just start out with an open mind to explore the industry. And the interesting part of data is the data career is you can explore any industry. You are not limited because every industry, every data, right? I've worked in the finance space. I've done oil and gas. I work on an oil and gas project. I've worked on e-commerce and all of those things. So if I decide and say this is the industry, I saw Arsenal posted the data engineering role, right? I could want to apply if I'm interested. So now what am I saying? So don't box yourself when you're starting out, because you might not have the luxury of opportunity in whatever space you think you are interested in. An example is football analysis. Let's say you want to dive into, that's the industry you're looking at. Now the question will be, how often do all this opportunity come out in those industries, right? You probably might be limited. So why not first build expertise and competence generally across all the industry, across different domains. And now when you build that expertise, that domain, that experience, you can now be intentional to go after those opportunities. So let's assume now I probably have an industry I'm interested in. I can be intentional and now reach out to those industry. Let's assume in this instance of, say, I'm interested in football analysis. All right. I could now be intentional to look for data scientists on LinkedIn or hiring managers on LinkedIn that in many of these companies, in many of these organizations. And that makes it easy for me. Now I know I can target these folks. I have experience that I can base on to engage them in the conversation. So that way, it's much easier. So that's why I encourage folks, if you really have, yes, I know you may have an industry in mind I think you want to explore, but you don't want to box yourself early on in your career. I think it should be more of have that breadth, right? Before you go into depth. So have that breadth, different knowledge, be a generalist as a way, work on different industry, gain that experience across board. And if you're not the industry you are interested in, you can now dive right into it and find a way to navigate into that industry. Okay, so I think that basically answered that. All right, so I will just probably in a few minutes just do a bit of intros on what DBT is. So like I said, DBT basically help. Is someone hands raised? Okay. So like I said, DBT basically help data analysts, in this instance, analytics engineer, work like software engineers. So it basically helps you to treat data assets. So when I talk about data assets, I'm basically talking about tables, your queries, basically help you to treat data assets like a code, the way software engineers would treat code. Now, I don't know if any of you have ever had to probably work on someone else's data code before. Probably someone left organization and you just pick up, you saw all their queries that they've written or all their DAX that they've written, and you find it difficult to understand how they work, what this is, the relationship between this and that, or you are in a situation where you have to migrate some code before to another infrastructure. Now you go through a lot of pain because some of the things software engineers enjoy don't exist in data world as it were, which is how can you easily see all the issues that have gone into that particular query to know that, oh, at some point in time, they changed a particular field, and this was why they changed that particular field. At some point in time, this was the history involved in this particular query and all of those things. So those software engineering principles that software engineers do that make it easy for them to collaborate such that even if you've never been, you just join an organization, all you just need to do is probably just interact with the code base, understand the code base, and within a few months, you're already contributing into that code base as software engineers. So how can software data folks also have that ability? And that's what DBT is doing. So it basically helps data professionals to leverage some of those principles that software engineers use that make them efficient, that make them find it easy to collaborate, which is they're able to test, they're able to do all of those things. And that's what DBT is doing. So a bit of overview on DBT and how DBT basically works. I'm just rushing through this. So now DBT sits at the center of your infrastructure. So remember I talked about the ELT paradigm where you load all your data from all different data sources. and you load it into data warehouse before you now do transformation to extract whatever data you need, right? So now DBT sits in your data warehouse. So it connects your data warehouse, and from your data warehouse, you can now do the transformation. So think about a world where you have your data warehouse, and in your data warehouse, you have three different rooms, as it were. So one of the rooms is where you have all your data that you've loaded from all the different data sources, say MySQL, coming from Facebook Analytics, coming from Google Analytics, all different operational DB coming from your core banking application, all different data sources, wherever they are, you load everything into that source, which you can call your data lake. Now, the next thing you now want to talk about is DBT now connect to that data source, now do all the different transformation of all the different data that you have, consolidate all of them, join everything, and not only extract the clean data that you need for your reporting and export them into another room, in this instance, which is called a schema or a database. So now you now have a database, which is all your sources, all your raw data, and you have another database or a schema, which is cleaned database. But don't forget, every other thing, all of them are both in the data warehouse. And that's just what DBT is doing. DBT connects your raw data source, which is in your data warehouse, do your data transformation, and now expose the clean data that you need for transformation, that you need for reporting, without having to do any of those things in your data warehouse. And that's just what DBT is doing. So a data scientist can just connect to that ready-made data, or a data analyst can just connect to that ready-made data and do what they need to do. So I just do a bit of intro in less than 5 to 10 minutes. So the intro will just basically, I'll just show you how to set up a DBT project, the core and the cloud. So I'll explain the difference between both of them. I'll just run some basics, some basic DBT code. So now DBT is an open source tool, so which is what you call the DBT core. So you don't have to pay for anything. And they also have a managed service, which is called cloud. Now, the difference between both of them is this. Now, for DBT core, you can develop, do everything you need to do in your local, show us how to install, how to initiate that right away, do everything you need to do. However, when you want to deploy your job, that means now when you want to deploy, you won't have to do it manually. There has to be a way for you to orchestrate the job so that you can say, oh, at every 3 o'clock, go and do this thing for me. Go and load this table from this source to my data warehouse. There has to be an orchestration tool that will do that for you. So if you are using the DBT core, so that means you have to find a way to deploy that job yourself by orchestrating that thing. And that's what DBT core is. So it's full-blown open source. Now, for DBT cloud, it also gives you that leverage to do your deployment, but give you that ability so that you don't need to bother yourself about how do I go ahead to deploy it. So DBT Labs team, the team in charge of that maintains DBT, actually handles all the deployment for you, and you don't need to do anything. All you just need to do is connect all to the data warehouse, and you're good to go. And the beauty of it is free for use for a one-man team. So that means if you are the only data person in your organization, you can leverage DBT Cloud without paying anything, and you are able to set up your infrastructure, migrate all the job without necessarily paying anything. So if you search for DBT Cloud, so if you search for DBT Cloud, you can register. So you can create a free account. So have a free account. I mean, so that if you create a free account, all you just need to do is just do everything, submit all of this, and you're able to create accounts. So when you create accounts, you're able to use DBT free for a one-man team. Because if you check, and the price is also very cheap for many organizations. So for a one-man team, it's free forever. But let's assume you have a team, it's $50, which is also very, very cheap based on what you need it for. So that being said, but let's assume you probably don't want to use DBT for the case in instance of this demo. I won't be deploying, so there won't be need for me to want to deploy and the like. So we'll be using DBT Core, which is the full-blown open source. So you need to first install DBT. And to install DBT, I won't also go into all the details, but you can just check the documentation. Just check documentation. There's also a good resource on how to install DBT. So let's assume you have all different options how to install DBT. If you're using Mac, how to install it. So now I'm assuming you already have DBT installed in your system. So if you now want to set up a DBT project, so you already have DBT installed, follow that guideline after the session, install it. So you already have DBT installed. So how do you set up a DBT project? Now, remember I said DBT basically give you the ability to work like software engineers. So that means you are talking about a version control system, which help you to track all the necessary things you are doing, such that anybody that interacts with that code base can have insight into what have been done. So that means you want to create a GitHub repo. So I have a GitHub repo here. So I could just, let's assume I want to create a new GitHub repo here just for that project. So I could just call this DBT student demo. Another I need to do is I create this. So now that I've created here. So now that I've created this, so the next thing I need to do is now I need DBT. Remember I said DBT connect to your data warehouse to load to transform your data. So I need a way to make DBT have access to that data warehouse, because if DBT does not have access to your data warehouse, there's no way DBT can run anything, right? So in order for me to make DBT have access to my data warehouse, I need to provide all the credentials that DBT needs to have access to your data warehouse. So let's assume you are using Snowflake. So that means you need to create a rule for DBT to make DBT have access to it. If you're using BigQuery, you can also try BigQuery. Google give you $300. Excuse me. Google give you $300 free credit to be able to have access to all the resources. So you can use that to try that to practice. So once you create, once you already load your data into your, say, Google BigQuery, the next thing is you want to provide all the credentials that DBT needs to access that. And to do that now, if you were using DBT Cloud, so let's assume I want to use DBT Cloud. So once you created an account, you come into this interface. This is DBT Cloud. I'll explain DBT Core and DBT Cloud. So all you just need to do is actually how to set up a new project. I can call it student demo. So I update that. Then the next thing is that I should choose a data warehouse, right? So by choosing a data warehouse, let's assume I want to connect to Snowflake. So I click on that, I click on Nest. So now it's asking me for all the credentials that DBT needs to connect to that data warehouse. So now let me just look for one sample that I have here in a second. Just give me a few seconds to pull up some credentials. Okay, so let me use this. So I have Snowflake accounts. This is the account, the database name. So I already have one created in my loop, which I'm just using to test. So yeah, I have a database credential. What's the name of data warehouse? Which is, what is data warehouse? Data warehouse. This was the role. So the username. So schema means where do I want DBT to transform all the data? So I could just transform it to a schema called SGAxOpeyemi. So let me test if DBT can connect to that source. Yeah, your test completed successfully. You are good to go. So I go to the next thing. So the next thing is I want DBT to which repo. So DBT is asking for which of the repo do I want DBT to connect to. So now I just created a new repo. So I can just provide, where's that repo? I can just provide that. And all right, so I have this available. So DBT has created what is called an SSH key. So which is the key DBT will be able to connect to that repo. So all I just need to do is I need to copy these keys so as to give DBT permission to that repo. So well, first, before then, let me just again. So I've copied out that code. So next, so let me start developing. All right. So now the reason why we're having this is we need to give, if I could not read the remote, please make sure you have correct access. So now don't forget, I copied out the SSH code. So now all I need to do is I need to come to this repo to come and create that SSH key. So I come to my deploy keys. I add a new key to that repo. And all I just need to do is I'll paste that key I copied out the other time. I just say DBT key. So I'm basically just giving DBT access. I remember my password. All right. So now let me reload it again. That should work. Okay, now, so we now have a new DBT project. So all I just need to do, I need to initialize it. So the moment I initialize this, now automatically DBT creates some files for us, which we can have access to. So now as an example, so if I see from here, now nothing has been created here. So let me just do something. Let me just commit this to that repo. So if I say commit, let me say create DBT project. And I commit. So let me reload this. So we see automatically that repo has been created. So let me just do a simple demo. Let me connect to data warehouse. So the data warehouse is somewhere here. That should be where I have a lot of things all over the place. I think it's here. Yeah, I think this is it. So let me open that data warehouse from here. So you can try this with your own credentials, basically. Just trying to use. All right. So now this data warehouse I want to connect to. So let's just see the data that are there. So now this is a development DB. So let's say I want to connect to the raw. So let's have, this is the raw that has the tables that are here. So that has all of these tables. So I have address. So if I want to preview, this is what the data look like. Let's say I just want to do a simple transformation. I just want to select the top 10. That's all. From this raw, right? So all I just need to do is, that means I need to first of all find a way for DBT to connect to this source. So now all I just need to do is, now I explained the other time that in DBT, in engineering DBT, you have what's called models. So models are just basically your select. They're just your select statement. So everything you're doing in DBT is basically writing select statement. So let's assume I just probably write a model and I say I want to create, okay, let me create a new branch. I'm on the main. So if I create a new branch just for text source, something like that, just a new branch. So while on that branch, I want to create a model inside here called top 10 address or something. So .sql. So everything you are doing in the model is our SQL files, and they're all select statements. So let's probably assume I do a select star from what's the name of the schema? Sure. Okay, so that's raw, that's public. So let's just do raw.public dot address signal. Okay. Check, where are we? I'm trying not to. Okay, so just for some best practices. Now, ideally, some of the best part of DBT is you shouldn't definitely select from your raw table like this. There's something that is called, this is part of my slide because I had to just rush through this, is dependency. So as much as possible, you want to create what is called a dependency from your data, which is why you don't want to select from all your raw data. Now, what do I mean by dependency? Now, one way DBT give you, one opportunity DBT give you such that if anybody pick your DBT project, the person can have an idea that, oh, these are all the tables that you have in this project. And this is a relationship that exists among all of those tables, right? And in order to be able to have that, is what is called data lineage or dependencies. And that's what DBT do. So it's saying in order to create that dependency, you must be able to, instead of referencing your tables directly, like the way I'm having the raw database, the raw schema, and the table, you should use some function, which is called, you have what is called the source function, the ref function. So all I just need to do is, so let's assume I go to the documentation. All right. The best way you can learn everything about DBT is in documentation. So we come to source. So the interface has changed a lot. All right, should be it. All right, so this is it. So you expect us to use select star from the source, which is the function I'm making reference to. What is the source name and the table name? So this is basically one of the best practices. Instead of having to select everything the way you would normally select. So it's saying you should select from this, right? And before you can select from, make reference to, okay, if I'm making reference to the source function, I'm calling the name of the source and the table is saying that you should first must have defined those source somewhere. Excuse me. And how can you define the source? Now you can see an example here. So let me just copy this. So that means the source is called Jafo, the database is raw, and the name of the table. So I will just copy this as an example. And I can come and create what is called a YAML file. Let's just call this source.yaml. So let me paste this here. But instead of the name of the source, I could just call this, name of our source is, let's call it raw or demo. Demo data, what name of the database? The database is that's raw. And the table name, I just pick one of the tables. I did that address. Addresses. So we have that. So now let's try and use that. So we have our select star from, same way we have that. The name of the source is demo data. All right. Comma. The table name is raw. So now in order to see what the query will look like, so let's just try and compile. Compile basically means what I've written, how we DBT interpret it if DBT wants to run this thing. Excuse me. So now for what we have is, DBT is going to run, so let's start from raw.demo. Now there's like raw demo data. So let's come here. Our schema in that table is public. We have that. Let's do a compile again. Yeah, and let me even run this from here. So we have okay, that's what we have it. All right, so let's try that here. So now we see that now I've only selected from, so let's now limit, let's say I just want to select just the top 10, limit of 10. And maybe do a transformation. I want to remove the address. I just need the address. I just need the states. Maybe that's just the simplistic transformation I want to do. So if I run this now, it should just give me that 3 and just 10 of them. So now this is what I have. So this is just the transformation I want to do. So now I've saved this. I'll now want to create this into my data warehouse, just this transformation. Like I said, oh, you're just saying this. You're just writing SQL statement, why DBT does all the necessary abstraction in the background. So all I just need to do is I run my DBT command, which is DBT run. The name of the model I'm running in this instance is top 10. So if I just run top _ 10 _ address, so if I run this, so automatically DBT has run it. And if I want to check the query that DBT is running, how DBT, so under the background, DBT is running a create table and I have all of this. So all I just need to do is if I want to check if what DBT has created, so I just need to go to my data warehouse. But now this time around, I'm going to check no longer at the raw because this is where the raw is. I'm coming here to come and check my development schema, which is where I have all my tables. I go under my DBT, which is what I've created for myself. Now I check what we have here. I'm sure we can see it already here. So if I just want to check what it looks like from here, let's say I want to check what I have here, if what I've created already exists. If I run this here, so automatically we see that we just have that top 10, only the address, only the state. Now you can do a lot of complex stuff. So all you're just doing is you're writing select statements and do a DBT run, and DBT do the abstraction for you, create whatever table, the output of the results for you in your data warehouse, such that whoever now wants to use this clean data, so let's say somebody need this data, this top 10 address, just the address and state. They don't need to do that again. They just need to come and reference this new view or this new table I've created and do whatever they need to do downstream. And that's basically what DBT does. Now I don't have them to go into all the complexity that comes with DBT. But let's I'm done creating this, and I want to commit what I've done, right? All I just need to do is I just click on commit and write a message and say probably extracted top 10 addresses from address raw or something. I commit it. Now don't forget I'm in a branch, right? Now I have to open pull request so that whoever is reviewing, whoever can see, even though you should be a one-man team, that means you really want to create your pull request and also merge it to the main. So whoever wants to see it, everybody can see what I've added. So everybody can see that, oh, I've added a new source and this is a query I've written. I can create a pull request, and I can also write documentation for it, more details. If I want to write more details, let's just say tested how to select from DBT source. And I create a pull request. So I can just merge it in this instance. I'm the only one doing it, so I can just merge it into main. Now that I've made it into main, now if I go to my demo, my main repo, can you see it has already reflected that? I can see that model extracted top 10. I can go to my models and I can see it here. So if anyone clone this particular repo, any of them can see what I've done in last few minutes and see all the details, the documentation that goes with it, and all of those things. Those are basically things that go into version control, into DBT. I can write a test. Let's assume you can see there's a test. I can write a test to check if the number of rows is actually 10. So let's assume I want to test to see if this thing is actually correct, right? I could just write a test and say, well, I don't know, my time is a bit fast. So let me write a test. Also an SQL statement. So like I said, most of your tests are basically SQL statements that would check the output, right? So an example, I can say select count, right, from that table I've created. But in this instance, I want to reference this table. And to reference that table, there's a function called ref. So I can say top 10 address. So now if I want to check if it will run, I can say maybe we're having, how do we check that? Okay. Now automatically what I'm doing here is if I go and check this, so automatically I know that if I run a count of this, I should get 10. But now, in order for me to test if that's valid, I need to write an SQL statement that would check if that's true. And that means I want to check whether if it's greater than 10. So that means if this is greater than 10 automatically, that means what I'm having here is not correct. And that's what this test is going to do. So that's just how testing basically works. And everything are all SQL statements. So you're basically writing SQL statements for everything you are doing. And that's why I said it's basically empowering data analysts. You already know how to write SQL. And since you already know how to write SQL queries, you're just learning to write some basics of some little syntax that is specific to DBT to do what you need to do. So I'll just stop here to ask questions because I have another meeting I need to jump in the next couple of minutes. Does anyone have any question?
Yes, I have a question.
Okay, please go ahead.
Like everyone said, we've been talking about DBT for a long time. And checking, so this was very enlightening. I just want you to, I know you mentioned briefly about how DBT gives an edge to data analysts. I'd like for you to, just give some more detail on the edge that DBT gives a data analyst. You're given an amazing test run on this, and I've been following through, but I just want to have more insight into the edge that it gives the data analyst in an organization. Thank you.
Okay, that's an interesting one. So like I said, the modern data stack and the analytics engineering role is still a growing one. Like it's still it's still in the nascent stage. And that's why not many people actually know how to do DBT. Now, if I want to do a pool of people that use DBT in Nigeria, I don't think we'll get up to 20. I'm not exaggerating. That uses DBT well, that know how to use DBT. So which means it's still a tool, and yes, it's a tool that has gained a lot of traction. If you follow data LinkedIn well, you see a lot of conversation that is spotlighting DBT and how it's fitting in the whole new modern data organization. So now where the edge basically come in is this. Even though yes, your ability to also use DBT is also a function of the organization you are in, which means are they cloud-based? Even though yes, you could set up a Postgres local and connect DBT to it, but if you really want to get the best out of the modern data stack and DBT, that means you're talking about the cloud infrastructure. And maybe not many Nigerian companies are leveraging cloud infrastructure. Maybe the tech startup are, but most enterprise are not, maybe for a lot of reasons, regulation purposes and all of those things. But most tech startup are leveraging cloud data infrastructure. So that means if you are in Nigerian space and even in global space, right? I get tons of DMs for organization hiring for folks for analytics engineers, right? So let's assume you are in Nigerian space itself. Yes, the whole awareness is growing for organization knowing that they need folks that they need as a way a one-man thing, which is what many organizations in Nigeria are looking for now. So which means if you'll be joining an organization, say as a data analyst, most often than not, I can bet you that if you're joining an organization as a one-man team, you would have to do a lot of infrastructure work because the data will probably be all over the place, will probably be messy, right? And now where does DBT give you an edge? Even if you won't be using it in your immediate organization, but just having it as a tool that you can use also give you an edge as relates to the kind of opportunity you can access, the kind of opportunity you can apply to. So that means you can apply for your general data analyst role that are probably just asking for the Power BI, the Excel, the SQL. And you can also apply for an ICT engineering role that are requesting for a strong usage of DBT. And that's why I said learning DBT as a data analyst, even though yes, it might be a bit of challenge doing how to use if you are not using it in your immediate organization, but like I said, the resources are free to use. You can set up a free local, free DBT cloud without paying anything. You can set up Google BigQuery without paying anything, $300 free for use for 3 months. The same for Snowflake, you can set it up for free to use for 1 month or so. So these resources are readily available for you to want to pick up the skill to learn. And if you're able to pick up the skill to learn, probably work on one or two projects, just able to solidify your knowledge. And so if opportunity comes for you to leverage in your current organization, if they have a cloud data infrastructure, good for you, which was this scenario I was when I was in my previous organization. They didn't have a data infrastructure as they were. Yes, it's a tech startup. They already have all their stuff in the cloud data cloud data. They already leverage cloud data cloud infrastructure. It made it easy for me to pitch it, the modern data stack and DBT, and it became very seamless to integrate all of those things. But if eventually you're an organization that probably and you are still leveraging on-prem, it might be difficult to push a tool like DBT. So which means you probably want to be learning it outside of work. But most importantly, give you access to assets to apply for more job opportunity in the global data space, because this is a skill organizations are really hiring for folks that can leverage DBT, because they know that yes, you as a DBT user that has good expertise of that tool, that means you can work as a one-man data team. That's the assumption, at least to help a startup that is just trying to navigate their data infrastructure, trying to get the best out of their data, and they don't have as well a lot of cost to hire data engineers, to hire data analysts, and all of those things to start getting value. So they know that if you're able to get at least an analysis engineer, that analysis engineer can easily set up the data infrastructure for them and also do the work of the data analyst in the interim to make reports, dashboard, and all of those things available. And that basically gives you an edge compared to just a data analyst that, yes, you've learned all your SQL, your Power BI, and all of those things. So it's just more or less like an add-on to your skill set as a data analyst. All right. Any other question from anyone? Okay, so in the absence of no other question, I guess I'll pass it over to hi, Mary. Are you on the call?
Yeah, sure. Hi. Sorry. I wasn't for a while, but I'm here now. So you were done answering the questions, yeah?
Yes, please.
Awesome. Oh, okay, great. So guys, no more questions, right? No more questions for Opeyemi. Wow, that means he did a great job, right? Explaining everything to us. Okay, that's great. So but personally, I think I have a few questions for you, maybe one. So as a senior data analyst, sorry, as a senior data analyst, what like getting into the job space, what should like employees look out for, like what their CV should contain, to attract employers, yeah, when job hunting. I don't know if you get my question.
I think I kind of have an idea, like what should anyone trying to apply for jobs or trying to get a job in data space, what should they look forward to having on their resume, right?
Yeah, exactly.
Oh, okay. So I think the first thing, I'll probably speak to the entry folks who are trying to break in, and maybe to the mid folks who are probably also trying to get another opportunity, as it were. So for the entry folks, I think, in all honesty, the fact that you're trying to break in, it's going to be a lot of challenge. That means you have a lot of hurdle to break in, and it's always very, very challenging for everyone to break in to get that first data job. So just trying to call it out so you don't feel a bit overwhelmed or frustrated when you're applying and you're not getting any feedback, as it were. It's just part of what it is. Sometimes it probably might take you loads and loads of application before you get the first job. And like I often tell people, it's a numbers game. The more you apply, the more you increase your chances of getting that job. However, I'm not now saying that you should just start throwing your CVs, your resume all over the place without being strategic with your application. So the first thing is, for the entry folks, before you start saying you want to start applying for a job, you want to ensure that you actually have like a portfolio in place, because that's like something that will also prove to any hiring manager to show that you really have the skill set you claim to have. Anybody can put data analysts on their resume. Anybody can claim they finished Google Data Analytics. Anybody can claim that they finished a bootcamp. But what will really separate you from that pool of other folks that's also job hunting is the portfolio that you have, which is like unique to you. So that means you don't want to put like a portfolio that is like what you just finished from a boot camp and which is like what everybody worked on. You probably want to say, okay, yeah, you've done a boot camp and you finished your training, or you finished a particular project, a particular course, and you finished the project. You probably want to now look for what kind of I want to work on an additional project just to solidify that I could use this tool, right? And that's what I tell people. So if you know that you've had a portfolio already, probably you could use a Disha page, you could use a Google README, a GitHub README to host it. Just have like a portfolio you can attach to your resume, right? So that's very key before we start talking about throwing your application out. So once you know that you've done that, you've checked that box, you have a portfolio of projects that solidify all the skill sets you claim you have. The next thing is, now most of the job, as it were now, most of them get filled via referrals. I think I can confirm to that, because I guess most organizations are getting to be aware that many people disguise as experts, whereas they're probably just learners, and which is why they want to lean on the expertise and experience of folks that are already in the field to recommend folks for them. And that means you want to, as much as possible, if you want to increase your chances of probably breaking in, I'm not saying it should immediately come true, but just to increase that chances of breaking in, if you want to be in a community where you are active as it were, so that when those opportunity comes, they will either come through the admins or folks that are already experienced and they can share them. Yes, there are some opportunities that get posted over the internet where they just tweet about it, they share it on LinkedIn. Yes, you can apply for those ones, definitely. But I'm just saying, for most of them, where you can say you increase your chances of easily getting those jobs are either through referrals and all of those things. So you have like a community where they drop all of this job and you can apply or indicate your interest to apply. That means you've narrowed down the pool of competition as against when the job get posted on social media, say Twitter, on LinkedIn, where you have thousands of people that will indicate interest. So just to reiterate again, so what do you want to have on your resume? You want to have your portfolio, which shows your case, the skill set that you can use, maybe 2 to 3 or 3 or 4, depending on the time you have. And you also want to at least have a community where they share of this job opportunity. There are a lot of them. You want to also be in 1 or 2 just to associate yourself with them and also have access to some of this opportunity. And lastly, as much as possible, you probably want to ask someone to review your resume. Now, by virtue of the fact that many recruiters reach out to me to recommend folks for them, I see a lot of folks' resume and I'm like, I know you are good, but if your resume is really off, right? So you probably want to ask people to help you review your resume, to call out some of those skill sets you have, right? So that it's just not all over the place, it's well formatted, just some basics, just some little information that anybody will want to leverage on. So just to at least have a good resume that is well written. So if you need like a professional, someone to help you review it, I think you should also do that. So that's from the pool of the entry level folks. Now for the mid folks that are probably looking for another opportunity, now you are not an entry level. So I mean, make it your job hunting is within a small scope compared to a beginner who has to find a way at least get that first job to get that experience. So you already have that experience to leverage on. So I think the best way would just be making reference to some of those most Slack channels. That's what I leverage. Most Slack channels that probably post jobs. And I guess also connect to probably certify some of those technical skills that's required. And just to call out, you still get tons of rejection. Before I got my current role, I got tons of rejections. So it still boils down to a numbers game. So I'm not saying the moment you apply, you get a job. So it's still a numbers game. You apply more only that, yes, you are a mid person. You have experience to showcase. You have projects to show that you know this stuff. Only that, yes, your chances are probably minimal because of you're in Nigeria as well. So location might just be an issue. But yes, you just have to keep applying. Join Slack channels where they post all these remote global opportunities. Also the popular ones like TopTal, like Turing. Just keep shooting the shot. Then one definitely will pot in. So like I said, it's a numbers game. I won't rule out that.
Awesome. Thank you so much for that. I think one of the things I picked out was community. I mean, this is like one of the reasons why the student community exists, right? Because we also place our learners on jobs, right? So we have partnership with a few companies like Paystacks and Co, right? So yeah, guys, community. I don't know if you personally have one specific for data scientists you could share with the learners. I don't know, maybe add it to your slide as a resource, extra resource. But yeah, I know they really would appreciate that. Yeah, thank you so much. And I think that's pretty much the question I have for you on my end. So I mean, that being said, I think we'll probably come to the end of this section. It was so amazing having you on board.
Sorry, I have a quick question.
Oh, okay. Yeah, please introduce yourself and should.
Hi, my name is AB. I'm trying to break into the tech industry, and honestly, I joined really late. I got really to be confused. But what I picked was building the portfolio. How does one go about doing that? How does one go about building a very solid portfolio for somebody like me that's just breaking into the analytics world, tech world in general?
Okay, I think looks like answer that. Oh, okay, you want to take the PMU, please do.
Yeah, I just want to reference. Yeah, I've answered that, but I actually have like a session I took on how to actually build a portfolio. So I want to look for it now and just share the link so that you could just watch that session. I actually go into details of what are things you can do and how to basically build your portfolio. So I'll look for it and share right away.
All
Okay.
right,
I
thank
don't
you.
know. I don't know if that's also possible to like add it to your slides so that you could just share the link to the slides. I think the
No,
committee will also be happy to reference some of the things you've said on the slide. I think you're muted.
yeah, I'll do that. I'll add the link to the presentation slide.
Oh, okay, awesome. Awesome. So, got any other questions? I mean, we could just quickly ask now before we end the section. It's almost 2. Oh, awesome. No other questions. All right. After all the back and forth we had, at some point I thought we really would not be having this. But delights me that you were able to make it to the section, and thank you so much. Thank you so much for having this with us. We look forward to inviting you for more sections in the future. Yeah.
All right,
You're
thank you.
muted.
Thanks for having me.
Oh, yeah.
Yeah, thanks for having me. Apologies, my schedule can be very, very overwhelming. So sorry for
Oh,
the
yeah. No, that's perfect. That's fine. That's fine. Okay, guys.
yeah.
Thanks everyone for joining in. Please do have a wonderful weekend and have a wonderful and amazing weekend of me.
All right, bye.
Yeah, bye. Yeah. Thank you, Lucas. Okay. Okay, also. All right, guys. See you all on Slack.